Okay, welcome to my stream. We're going to be once again playing around with quality as we try to hone in on the correct bitrate settings to make both YouTube and Twitch happy. It looks like YouTube is happy with the current bitrate, and Twitch is not killing the video, but it's trying to determine the bitrate. Okay, so we're gonna have a little bit of latency. So I'm gonna be sorry if I get delayed to talking to the questions. I need to figure out how to get a better latency going. But throw comments in. I am probably just going to let people join for a few minutes, but I'll probably give we can go over a quick overview if anyone has any questions of what's happening. And I can add a better, more detailed introduction. But today, we're basically going to once again tackle the AIE-MLs. I figured out the issue that we were having before. The system really wants you to put the whole platform onto a SD card and load the SD card here and run it. I don't want to do that while I'm doing a bunch of different developments. I want to be able to know how I can own these AI engines in the AI engines in bare metal. Hello, Mosne123. Welcome to another battle with AIE-MLs within the Versal ACAP. Okay, so quick overview of what we've done so far. We introduced how to do a basic, I guess, platform for the Versal. We did debugging on, or we did some basic application loading onto the A72s, the R5s. We could dig a little bit more into the platform management controller, which I do want to do. But today we're looking at how we can actually utilize these AI engines. These AI engines are not easy to use. Xilinx, AMD Xilinx definitely hides in between several layers of abstraction, and they want to manage it for you. I don't like the system managing it for me. I want to be able to do bare metal applications and load out different AI configurations during operations with a bare metal application. I don't want to rely on some Xilinx service on the Linux image. I want to be able to load these AI binaries from a bare metal application during operation. And that might be as simple as having the platform manager point to partial PDI files to load in new systems. And we'll play around with that maybe a little bit later today. But today we're going to finish the tutorial we were doing last week, and then we're going to look at a new tutorial. Once we finish that tutorial, if we have extra time, we'll look more into how we can manipulate the bare metal application to be able to configure the AIE engines more dynamically during operation. The tutorials and guides were not useful. They're mostly simulation based or mostly Linux based. There is there's only one. The initial example from the vendor really supports bare metal operation, but I want to kind of explore more on that. Okay. We're using the iWave. This is a Versal AIE Edge 23 VE2302 part. I personally like it because AMD Xilinx is hoping to qualify it for space, and my goal is to look at more of a space application. How do we provide space functionality, reliability, performance to the various components within this device? And that's kind of my aim. But everyone, this is a good embedded AI platform. We're going to see it. Be interesting to see how it's introduced in products going forward. Okay. So, let's go back here. So we had several different applications, right, that we are trying to fix. And so what we initially do, right? So initially we loaded the platform right here. So this is our initial platform for Vivado. We introduced an AIE configuration. And if we go to the reports for this, we can look at the graph. See, this is the functionality. We have a stream input going to one processor, going to another processor, back out to the Fabric PL stream. We can see how the system implements this within the design. We have our two PL streams here, and they're routed through the various little like NOC memory units. This processor unit, which is actually taking both functionalities, because there's a processor load, and if you look into our operation, we wanted the processor load to be 10% of the processing cycle. Don't know exactly what that means, but one processor is doing 10% the first function, 10% the second function, and the instructions for these processors are actually located at the very top. So here, I believe we have the instructions and, these are the buffers. So those are the buffers. And here is this mod. Where is the ELF files loaded for these? Is it just those buffers? No, it can't be. Maybe it's small enough to put into the caches? I'm actually a little confused by that. Oh no, these are the buffers here, and these are the executable. Buffer 0. No, there's a buffer 2. Interesting. Buffers, BIOS kernels. And they don't really tell us where they're located. Okay, so we introduced the AI kernel to the platform. Then we introduced these HLS kernels, and these HLS kernels are simplified DMA cores, and these DMA cores are also introduced to the platform. And using the system project, we link all this together. And if we went into the hardware link, and if we go into the binary container, and just keep going down and further down, right, to the project level right here, we have the Vivado project that's integrating all these systems together. So this is kind of a thing where you make a project in Vivado, you bring it to Vitis. Vitis takes your kernels and introduces it to your Vivado project. I don't like it so much because you don't have like complete control over how the addresses are going, how systems are hooked up, and whatnot. So if you ever want to manipulate it, I think you can open it up, manipulate it, produce an XSA file, and then bring that back in as your final target. And that's what we do here. Right here we have a new platform, A to Z, and this is with the AI engine, Fabric all updated. And then we have Hello World that's based upon that image. If we go to where's the BSP settings? Does it say okay, yeah, right here. It's on platform A to Z. So we're using platform A to Z right here. And I tried to run it like we would done our other things, and the system kept failing. And so I found out what we're missing. So, okay, now we're back to where we ended last stream, like I don't know, 2.5 weeks ago or something. And we want to be able to use the AI engines with our little application over JTAG. So if we go to package, we go to the boot image BIF right here. There is a compiled, whatever, binary here. So first thing first, I took out the processor one, but first we have the PDI file. So this is basically your NOC configuration and your Fabric configuration, your DDR configuration, whatever. This is your kind of your generic Versal bit stream. And then after that, we have these AI engine binaries. And these binaries are actually generated within the output of the simulator here, the CDOs right here. So we have all these CDOs, and it would be good to trace how these things are generated so that we could potentially do it. It's just like a file path. Yeah, I want to figure out how these configurations are done. That's for later. So we have the CDO files, these AIE CDO files, and then they're compressed into or not compressed per se, they're merged into one binary. So to get the AI engines working, you need to have this PDI file and then this AI merge CDO binary. And this is all compiled into the boot.bin. We're not going to read that. So what I did to resolve our issues to be able to test the bare metal AI functionality over JTAG was to go to our launch settings here, and instead of the PDI file, I now have the boot.bin file. And so I'll demonstrate it here, and then we're going to try to do the GMIO tutorial. And then if we have time, we're going to look at how we can play around with the deployment of the CDO bin binaries. How can we have dynamic deployment of AIE CDO binaries with bare metal? That's kind of the goal I want to see if we have time later with this stream. Okay. Any questions? Does anyone want me to poke back at the configuration so far and the fix with the AIE CDOs? If not, we're going to roll forward and we're going to demonstrate it. Okay. So best way to demonstrate this is to show, okay, this is the old one, so we're going to kill this, and then we're going to do a screen again. And here, see, fortunately, I do not have good window management this. Okay, we're not going to be able to, we're going to have to hit play and change. So let's see, can we, I want the debug console over here. That looks great. Okay, so what we're going to do is we're going to hit run and then look at the debug console. I'm probably going to kill it, so it's a fresh restart. Okay, so we're going to have to redo this. Okay, we're good there. So we're going to just execute it. We're going to go run, go here, and go here. Hopefully everyone can see. Let's see how this goes. So let's try to watch what XSDB is doing. So right now we're loading the boot.bin. We are getting a bunch of additional information from the PLM. And then looks like we loaded the software. Cool. Then on this side, we have the initial PLM software that we had before. Then we got into our API and running the system. They do the DMA, they do this, and then it checks it, and we were able to run the application without any errors. Right? Look at us. Make it zoom in. We were able to run the AIE-ML application without any errors. Okay, so what we're going to do, we're just going to create a new workspace. We're going to load in that same platform, but we're going to try to do a GMIO example and get it working with the bare metal. So let us attempt that. Okay, so here, let's bring this back down here. No, be with these guys. There we go. Okay, so let's open up a open up a workspace. We're gonna be here. We're gonna call it GMIO 0. Hit OK. And I'm gonna try to do this blind. I don't have the tutorial open up at the moment. We're gonna try to just go with what we know, right? Like, let's try to see if we've learned how to do this appropriately. So we're gonna create a platform. We're going to do a hardware design. And the easiest thing to do is just we're gonna go here. We're gonna go to this existing platform, right? And we're gonna go to the export of the platform. Oh, good question. Which one we're actually targeting? Which one's the newest? I think it's going to be this one, right? Now, okay. Go back and see which one we're actually working with. We can switch back in a second. I want to make sure we're right. All right, it's gonna get awkward. So platform settings. We are using AIE BD. Okay, great. Now we're gonna switch back. Try this from again. Try this again. Okay, cool. We're gonna do a new platform component. Browse. Yeah, we're going back to the simple platform hardware. We're gonna do this one. And next, I'm gonna think for a minute as it looks for the available processors and targets within the system. Okay, so we're going to go AIE runtime and hit finish. And then on the platform here, flow, we need to build it. We've generated it. Now we're going to go to examples and we're going to hit GMIO bandwidth. We're going to hit that one. We're going to create GMIO bandwidth on our custom platform. Yeah, I need to look up some background to do of mine. Okay, now we have a component. And we have to create what, a system? What did we do last time? Okay. Okay. So we're just going to go here. We have different simulators. We're going to need to put a the first thing we're going to do is we're going to build it. And then we may try to run the simulation and see what happens. Hopefully it works. But I want to build this and look at the report so we can see what the system is doing. Then we're going to look at system integration and then play around with how it's supposed to work. So the GMI bandwidth is going to be stressing the knock, and as soon as this builds, we'll show you what it's doing to stress out the knock. Let's look at the kernel here. It's going to be graph.h, right? So here we're creating an input GMIO and an output GMIO. So before we're doing the PLIOs, which were connected directly to the fabric, and these GMIOs are connected directly to the knock. So instead of using Axis Stream, we're going to be using the knock packet format to bring data in and out of the system. And our build failed. Why did the build fail? Problems. Oh, we have to add the library things again. Ah, okay. Cool. We all hate this, but we have to add the appropriate libraries again. It ran just fine before. Oh, licenses are not found. Did that not? Okay, let me check the licenses real quick. Um, okay. So get those up real quick. Okay, looks like we're good. Let us try this again. This should be, the license should be built into, so license is free. So this license you can get free from the website, but this license should be built into the next version of Avado, Vitus. So Vitus 2000 or 2024.1 should have this license built into it. So you don't need to have a dedicated license for it. But saying that, it's also free right now. So this isn't a paid license. So don't, if you want to be able to use these materials, be able to build these things, you do not have to pay. Because it's AIE to build. So the AIE to build license is free. You just need to have a dedicated version now, and then you don't for the next version of Vitus. Oh, chess. Okay, let's make sure our system doesn't peak. You, if you do too many threads on your system, you may run out of memory, which is not good. AIE complexity is low. That's good. Feel like class. Okay. Build is finished. So let's look at the graph real quick. So we have GMs instead of PLs. And does the array show anything different? Yeah, it just says these are GM IOs instead of PL IOs. And we're still just probably doing a generic bandwidth test. So we built it. In the output, there should be a PS control, AIE control. There is a load elf function. Okay, this is weird because it's expecting to have the proper directory. Initialize graphs. You're not going to find that path. Okay, so let's run the simulation real quick. And then we need to try to link the system, rebuild it, and see how it works. So we should have a data output, the data bandwidth text. Okay, so now let's try to incorporate that. So we're going to do a new component system project. Sure. We're going to do this platform. Sure. We're not going to do any of these. Finish. Okay. Add existing component AI engines. Add that to the bandwidth. That's all we should really need to do. Okay. That should be good. Okay. We're going to need to reincorporate the processor application. Oh, we didn't. Forgot to add the magical text. We wanted to say that this doesn't run unless it needs to. We'll see if it works. It works, and maybe we'll try it differently. Because there's a wrapper. If define wrapper. I guess it's right here. A sim. Yeah. We should probably like do that. I may want to. Okay, it's building. Ah. Hopefully this doesn't take too long. What am I building this container? Yes. Okay. What are we doing next? Yeah, we can add those binaries, those libraries. Those are very important. And be a larger heap size to do all this fun data transfers. Okay, no. Sorry, I'm just trying to read through all these instructions. Yeah. So maybe we can, let me bring this back over to show what we're working through. Okay, so I'm just trying to make sure we follow all the steps appropriately. And there's just not much useful, right? Um, so let's go to the hardware flow right here. Um, so, okay. We do have host CPP. Okay, maybe we can try out these things. Oh, so much to look at, trying to figure out all the different. So they have, this is host, but that's not system, right? We don't, do we have, uh, are we targeting, what are we targeting here? Where's the host CPP coming to play? Host, I'll examine the kind. Maybe, okay, okay. Yes, this is looking complex. Yeah, I'm getting the fire hose at the moment of all this information of we're trying to figure out how do we deploy this on the processor. Yeah, because they really want you to run the media and run it on the host. That approach. So we're gonna figure out how to transfer these blocks. Um, how is that okay. Maybe we can deploy this. Okay. Yeah, that's what I thought. Okay, so here we're going to add great little define. Copying that again. And then at the bottom here, we're going to do a end if. Okay, and we're going to rebuild it and then redeploy it on the system. See if that works. Oh, hopefully don't spend too much time being frustrated trying to understand how the system works. Okay. Oh, I should probably apply that on the binary connector. So edit a binary container. So open this. Now where do they want us to go? that. We want to generate XSA file. Okay. Oh, good, good. Finished. Go here. Work. Sure, we'll build it along. Okay. So here in the processor section. Okay, yeah, this stuff will be more important later. Okay, here is the really cool configuration. Initialize AIE control. This, so that's the init. Load L. Oh, we have to figure out that define. Okay, so we can remove it and try to connect it. So they're saying there's a work here. In the work, we have like the AIE file, release, and some information. CDO files. I only have the built into it. Okay, interesting. PR load. Okay, let's go to definition. No, no, we broke it. Oh well. We'll watch it build and see if it builds appropriately. Okay, let's open up Vivado and watch the build. Apparently, I broke it otherwise. Oh, that was painful. Okay. Okay. Now we're going to open project. We are going to find this magical little section. And DMIO0, system project, hardware link. No. Sorry. Build, hardware emulation. Why are we still in hardware emulation? Did I miss a step? Come back here. Where do we change the target? Okay. Targeting hardware, component, run. Figure the hardware. Add the components, add the connectivity, generate the XSA file. Oh, is there a build section? Am I doing the wrong section? We go to system project. There is no hardware emulation, no software emulation. We are building real hardware. Go. Sorry. Sheesh. I need to make sure. Just pick the correct option. Okay, as soon as it builds the project, you can maybe go watch it build. But yeah, going back to the output here for the processor. Oh, that's interesting. Work directory, A111. Oh, that's the location. Interesting. AIE-111. I don't actually know what it would be looking for in that situation. It would have to be like go to definition here, but we need to get the pre so this is useful. I like this. We need to figure out how we locate. They're just asking. It might just be asking for an ELF file. That. Let's find this file. Great, you found it. Useful, but not what I wanted. You're thinking. Okay. Generating the targets. How are we doing? Okay. I need to think about how we're going to approach figuring the AIEs. We need to hunt down these files. So these files are located here. So let's go. Let me open up the VS Code location. Can I? I guess we could just be like, me. Okay, yeah. We'll just open that directory and explore it. Okay, we are going to open a folder. That folder is going to be other locations, computer, be under tools, Xilinx, Vitus, 3. We're going big. AIE tools include AIE tools include. Yeah, I think we should just open up this whole thing, right? Yeah, I trust the authors, right? So much that we don't. They're all H files too, filed somewhere else. Okay. So the ADF is how we deploy things. So here is where we saw these things. Can I right click? No. So we want to go to common layer. Any functions declared? Structure. And control. Big. Where is elf file? Find in files. What's the file? Maybe control. We want that there. So we have partials. Oh, we got so much more to look at. This is dangerous. So we have load an elf file. We give it an elf pointer. We have load elf memory, load elf section, load elf section block, load elf partial. Are these located anywhere? Cool. Just here. Did I not? Do we need to go up a folder? Did the includes? Okay, let's jump up a folder. Find in files. Just that section. Okay. For the yarn. Doc. There. Data. 2302. Open anyways. It's JSON. Yeah, text editor. JSON we can't read. Great. Lib. Devices. Okay. Okay. Put that back away. Let's not worry about that. Already looked at platform. Nothing big. Rips. I'm confused why it says plan ahead in IDE. Why is this on vertex 4? This is so weird. Why is there ISE for AIE engines? Were these things existing back with ISE? No, no, no way. No way. No way. Maybe they were doing soft versions on those systems. But what? Why are you here? Okay, this is confusing. Looks looking through files. Okay, that's great. Great. I'm done. Are you done? You are generating stuff. Let's go look at the configuration real quick. Hardware link, binary container, Vivado, VPL, project. Let's go look at the block diagram. Okay, let's go see what V++, the Vitus linker, did to our block diagram. Oh, this is only hardware emulation one. Oh, whatever. We can go look at the other one. Okay. We have a work directory. Is that used anywhere? I don't see it used. To just make that as a reference. It's used there. Okay. We have it in 3, so it's not used. That's pointless. Here it's we're loading the ELF file. So I guess we could load that somehow within the system. What's the example look like? Back to source. Source. Right. There's an init where there's not really like a load ELF file. Just do gr init. And that gr init assume is coming from here. And so we want to do like a load ELF. We want to do an init. What is not running an enable, it just runs an init. Gives a pointer. Guess we could do that as well. Run. We wait. See what happens. Okay, back here. Okay, getting close. Let's go look at Vivado again. So this inserted our AI engine and added a port right here. That really everything? Yeah, it really just added a port right there. So if we go to the NOC setup, we see now we have a blue block or a green block. No, we have a blue block. The blue block is the NOC doing the request back and forth. Okay, let's go ahead and close you. What time is it? Okay, I'm not sure how much further we're gonna get. This is proving slower and more difficult than I expected. Okay. So we have an XSA file, build finish. It's great. So what we want to do now is we want to go File, New Platform. We're going to call this platform with the GMIO. And we're going to do hardware design. And because no one tells you how to find these things, we're just going to do our best. And go. We got to build a hello world with it. And then we need to make sure that we get everything appropriately linked. Okay, so yeah, standalone. Then we're gonna deploy a hello world example after we build the platform. So as soon as we get up and going, we will build it. Okay. Okay, that doesn't really work. Okay, so we are here. We're gonna build this. Shouldn't take too long. Then we're gonna do a hello world. We're gonna execute the hello world, and hopefully it goes well. So no, we're on the processor. We're just hello world. Get a hello world template. Yes, we're gonna do platform GMIO. We're gonna do on a standalone A72. Finish. We're gonna build. We're gonna run it, and we're gonna add all the links for the we're getting the processor includes working. Okay. Yeah, we'll have to probably pull up another Vitus so we can see how it works. Yeah, we got stuck on something again. So I guess let it wait out. Okay. Okay. You make a to-do list of things to try to get this to run. First off, we need to package the system project so we get the AIE cores. Then we gotta link the appropriate files or include the appropriate files in the Hello World project. Be able to work correctly. Oh, wow. I'm gonna have to do this kind of on the side and try to demo this better. Okay, so what are the struggles here? What have been the struggles? The struggles have been mostly time. We've kind of looked at how the processor can configure the connectivity of the systems in bare metal. So now we just need to do it ourselves. So I still want to do the GMIO example, and then we're going to try to go back to the simple example and get the processor to configure everything manually. A lot of work. Okay. tired of this thing having troubles like this. I blame Vitus. Okay. Well, why we wait? We kill it? I don't want to kill it. Give it like. What time is it? Okay, is it slowing down? Did I just close it? No, I closed something. Yeah, it's still not happy. Annoying. And it's not easy to kill it. Okay, I guess we'll go ahead and kill it the fun way. Down here. 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 Kill process. Okay, let's try this again real quick. I'm probably gonna go get the hello world working, and then I'm probably gonna have to take a break. I should do a subathon or whatever. I should do nonstop. Just stream nonstop FPGA development until I get it working. Just show my anger at how annoying this system can be. Here. Okay, let's go back here. Ugh. FPGA subathon. Worth it. Maybe later. Okay, flow. Back here. Okay, go ahead and build, and we're gonna try to launch you on hardware, I guess. Power cycle. The hello world should work. I don't know why it wouldn't work. Let's guess we just hit run. How do we launch it? New launch configuration. Local. Sure. Yeah. Let's okay. Back the mobile X term. Here, let's get this back up and running. Zoom out a little bit. Get that. Okay. Run. Just gonna be happy. Okay. I believe. Okay. Got the hello world working. Let's try packaging this guy. Get the link working. Go ahead and build the package. Sure. Be done. Okay. So we got that working. We got that working. So let's just do the easy thing real quick. We're gonna go to Hello World, launch settings, change this to the boot.bin, and just see what the system says. Build hardware package boot.bin. Yay. Okay. Okay. Now we're gonna run it again. Let's see if we see the AI engines are enabled with the boot.bin. Then we just gotta figure out how to run the GMIO from the processor. It'd be fun. Okay, it didn't really say it this time. Interesting. Okay, so we need to get the processor to properly execute the system. It is configured, it is running, it just needs the processor to provide data and operate on it. I didn't even look at the kernel. No one look at the kernel. What is the kernel doing? The kernel has a input buffer and an output buffer, and it's going through 32 cycles, grabbing a J value, and it's squaring it. So yes, my square. So we have a square kernel operating in the system. We need to be able to give it data. Okay, we'll do that next time. We'll be GMIO interfacing from the PS. Thank you for joining us. Really do ask questions. Try to drive conversation either today or next time or whatever. Tomorrow we are going to be, what was on the list for tomorrow? Post about it later. Looks like we're looking at trying to do a soft processor in the Certus Pro FPGA. That's our goal for tomorrow. We'll see how far we get through. Okay. Thank you for joining me. Leave a like, subscribe, share, do what you feel will help the FPGA community.